Welcome to my YouTube channel. In case you are new to this channel, please subscribe, of course, and share. Okay, so I haven't been posting videos on calculus 2. Okay, but one of you guys asked for help, and I thought I should consider that. So I'll start posting videos on calculus number 2, and I was given the question, the draw sheet from one of you guys. I received draw sheet. One of you needed help, yeah. So I received a draw sheet number 3 on integration. So I'm going to solve almost all the problems from this draw sheet, and I'll keep posting them here. So every time I'll make sure you click, okay, my YouTube channel, you subscribe, and then you get the notification, okay, every time I post a video. So without wasting much of your time, let's get started. Okay, so we have this problem number 6. I got this question from iteration number 6, right? Or iteration number 3, problem number 6. Okay, and the problem reads, evaluate the integrals. Okay, so we have the first integral here, or the second integral here, and we have the third integral there. Okay, so it's very important to know which integration technique is suitable for each problem. Okay. All right, so I'm going to start with the first problem here, question number A. So question number A, we're integrating x squared times tan inverse of x dx, okay? So what are we supposed to do here? So which integration technique are we going to use? Okay, use substitution. Are we using that? Why? Okay, if you look at this, we have a tangent, tan inverse, right? Okay, and we have an algebraic function. So we have an inverse function and an algebraic function. Every time we have this combination, guys, just use substitution here. Okay, so integration by parts. So we have to use integration by parts here. The reason being is that if substitution is not going to work, remember that every time we're using this substitution, when you say let you got something, when you take the derivative of that something, must be able to cancel out the other function, right? To cancel out the other function. But here, if you say let you equal to x squared, you differentiate x squared to get 2x. 2x is not going to cancel out with this, okay? At least. And similarly, if you say u is equal to tan inverse of that, it differentiate tan inverse. That tan inverse is not going, the derivative of tan inverse, of course, which is 1 over x squared plus 1, is not going to cancel out with x squared, okay? So here, there is a problem. So use substitution cannot work. Instead, we are going to use integration by parts. Okay, so integration by parts now, it's a matter of choosing which one is u. Remember that integration by parts is in this order, right? U dv, right? So you have to choose which one is a u, which one is a dv. If you pick u, the function that remains, everything that you see becomes dv. If you pick this is my dv, everything that you see becomes u, right? Okay, so the order of choosing u, I follow this order, if I remember very well, L-I-A-T-E, right? Logarithmic function, okay, inverse trig function, okay, algebraic, trigonometric function, and exponentials have the last choice, right? So if you look at this combination here, we have, do we have logarithmic function? No. The next is inverse, right? Function, tan inverse, yes. So this one here is going to be my u, okay? It's going to be my u if I follow this order here. Algebraic comes after inverse, right? So I'm going to make u equal tan inverse, okay? So my u is going to be tan inverse of x, okay? And then what remains, since I've picked my u to be tan inverse of x, whatever remains now becomes dv. That is a function I need to integrate to get v. Okay, just a reminder, integration by parts is equal to what? V u or uv minus the integral, okay, of v du, right? So we need to have a v. Where do you get v? V is gotten from the integrating dv, right? Okay. And then you just pick it direct from here, isn't it? And then, you know, here in the integral v already, you get by integrating dv. And then you get it from Well, you differentiate u, right? It's a derivative of u, isn't it? Okay, so let's get started. So as we said, our u is going to be a tan inverse of x, right? Okay, so every time we have a u, make sure you differentiate it, okay? So what is the derivative of tan inverse of x? So du dx, you need to remember this, right? Okay, if you integrate, okay, x squared plus s squared, right? Or let me just make it simple. X squared plus 1, right? This is equal to, it gives you tan inverse or arctan, same as arctan, right? Arctan of x, right? At least you know this, right? Okay. So the integral of 1 over x squared plus 1 is simply tan inverse of x. So meaning that if you differentiate tan inverse of x, you get x1 over x squared plus 1, okay? It's just opposite, isn't it? So meaning the derivative of tan inverse of x is simply 1 over x squared plus 1, right? Okay. So remember that we need to find du. So solving for du from here, from this derivative, making du the subject of formula, you're going to get what? Dx over x squared plus 1. At least we know this, right? Okay. Next, so means I've picked out my u from this, right? What remains is my dv. So my dv is equal to dv, then what remains there is x squared dx, isn't it? Okay, I think that's what I have from there. X squared dx, these two. Okay, so I need to get dv. So for me to, I need to get a v. For me to get a v, I need to integrate dv. So my v is equal to the integral of x squared dx. And what's the integral of x squared dx? Okay, I'm sure this is very straightforward for everyone. Okay, so this is just x cubed over 3. Okay, don't put c this time around, please. You put c at the final result. Okay, now let's substitute our integration by parts formula. Okay, so we're integrating x squared tan inverse of x dx, and this is equal to, we follow the order now, v times u or u times v, whichever order, doesn't matter. So v times u, this is x cubed over 3. Okay, just a minute. Okay, x cubed over 3, and then our u is tan inverse of x, right? Okay, minus, okay, now we have the integral here, the integral part, integral v times du. Okay, so what is our v? Our v we said is what? Our v is x cubed over 3, isn't it? Times du, and my du was equal to what? Dx over x squared plus 1. Okay, so let's simplify this. So we have x cubed over 3 tan inverse of x minus 1 over 3, the integral of x cubed over x squared plus 1 dx, right? Okay, now we're still going, right? Okay, we're done with this part, yeah. But here we still need to do more integration. So we have to integrate x cubed over x squared plus 1, isn't it? Okay, so how are we going to integrate this? You see, this is an improper fraction, right? Okay, we have the power here of x on top, which is higher than the power of x in the denominator. So we have to divide this, okay? It's an improper fraction. It's more like a 5 over 2, okay? This guy is small here, okay? That's child abuse, right? So let's do something to this. So I'm going to do the division here. So x squared plus 1 is going into x cubed, right? So if you remember mathematics very well, division, right? X squared plus 1 divided into x cubed. So I'm going to write this in the order of reducing powers of x. So x cubed, the next one will be x 0x squared. Okay, the other one will be 0x plus 0, isn't it? Okay, I'm just trying to write in the order of those powers, isn't it? Okay, so how do you divide this? You just don't bother saying x squared plus 1 into this. Okay, please just divide x squared into x cubed. How many times does x squared go into x cubed? It's only once, right? Okay, it's x times, of course, what remains there, right? When you divide x, not once, okay? When you divide this guy here, the result is what? X, isn't it? So this guy goes there x times, isn't it? Okay, so, and then you multiply, okay? What do? You multiply, isn't it? So x squared, x times x squared plus 1, what do you have? We have x cubed plus x, right? Okay, x times this, x cubed, x times 1, you have x. Oh, and this is our math that we were taught. So I need to, instead of writing x, I'm going to write 0x squared because I need to follow the order, right, of powers. And then my x will come here, right? Sorry, plus x. My x will come here, and then the constant again is 0 this side, right? Okay, I'm doing this so that I can subtract the x's with the same powers, isn't it? Okay, there's no effect, just no. So let's subtract x cubed minus x cubed, this is 0. 0x squared minus 0x squared, this is just 0 also. Okay, 0x minus x, so same as 0 minus x, we have negative x, right? 0 and all that. So this is the remainder, isn't it? Because now you cannot divide this x squared plus 1 into this again, okay? It's a remainder now, okay? So it means that my new integral is going to look like this time around, right? Okay, we said that, oh, this guy goes into this, right? So if you divide, if you divide x cubed over x squared plus 1, this tells me that, okay, this guy goes into this x times, and then remainder is x, so minus x over the same thing, right? So why am I writing like this? You guys remember that if you have 5 over 2, you say, okay, 5 goes into 2, it goes into 5, how many times? 5 times, right? Okay, a plus. Sorry, I'm so sorry for that. 2 goes into 5 is 2 times, right? Okay, and then what's the remainder? The remainder is 1, and then over the same 2, isn't it? That's how we can write 5 over 2, right? The same thing. So this is the same thing that's going on here. Okay, so x squared plus 1 goes into x cubed once. The remainder is a negative xy. We show that, okay, this was negative x. Everyone has seen this, that was to give us negative x as a remainder, isn't it? So this is a remainder here, and then over the same divisor, okay? So let's now simplify this. So I'm going to replace that, what I have inside the integral, with my new function. So you have x cubed over 3 tan inverse of x minus 1 over 3. So inside here, I'm going to replace with what? What I got after dividing these two, right? So I had x minus x over x squared plus 1. Okay, dx. So this is what I got. You can try to check, expand this, multiply this by that, you subtract, you're still going to get the same thing, right? Okay, so now let's simplify further. We have x cubed over 3 tan inverse of x minus 1 over 3. Now we can now integrate these guys separate, right? What's the integral of x squared? The integral of x, this is x squared over 2, right? So here we have x squared over 2, at least you know this, right? Minus, okay, what is the integral of this? Guys, let's also integrate this. There's something you need to do here as well, right? Okay, so for now I'm not going to integrate it. What do you think we're going to use? Which integration technique do you think can use here? Okay, come on. Okay, I know. You see, u substitution is going to work, right? Because if you make u equal to your denominator, you differentiate, you're going to get 2x, and that x is going to cancel out with what you have in your numerator. So this time around now, u substitution is possible to use, right? Okay, so on this one, I've already used u. Oh yeah, I've already used u, guys. Why should I keep on saying u? I'm going to use another letter just for this one, okay? So I'm going to say, okay, let, what should I use? Let p, right? I'm just going to use p is equal to x squared plus 1, right? So every time let something equal something in integration, you also have to take the derivative of that, okay? So dp dx, this is equal to 2p, right? So remember that we are changing this from x to p, right? So everything has to be in terms of p. So it means that even the x has to be substituted with its counterpart dp, right? So let's solve for dx. So dx from this, if you notice here, how to be the dx? If you make dx the subject of formula, you are going to end up having what? dp over 2p, right? Is this correct? I think it is correct, right? Oh, this is, oh, there's a mistake here. Sorry, guys. This must be 2x. This must be 2x, not p. Why did 2x p? I mean, where did p come from? Okay, so this is my new substitution now. So I'm going to substitute that, right? Okay. So let me just get rid of this. Okay, so you have x cubed over 3 tan inverse of x minus. Oh, here I can just simplify this. Of course, this is it, x squared over 6, okay? And then plus 1 over 3. Why this plus minus there, right? Okay, and then here what I have here is the integral x. So in place of x squared plus 1, say this is the u, right? Remember I said u is equal to x squared plus 1. In place of dx, oh, this is what? We said is what? du over 2x, if you remember very well from the previous. Okay. Now, if you notice here, x and x can be cancelled, isn't it? So I have 1 over 3 and times half, right? Outside here, this half can be pushed aside. You're going to have 1 over 6 together, right? So x power 3 over 3 tan inverse of x minus x squared over 6 plus 1 over 6, the integral of 1 over u du. So what's the integral of 1 over u? This is something that is very, very, you're very familiar with. Okay, the integral of 1 over u is simply natural log of u, isn't it? So x power 3 over 3. Oh, why am I saying you guys? This is a p. I say this is equal to p. I keep forgetting. I'm just used to you. This is a p, okay? This is a p. And this is dp as well, okay? So tan inverse of x minus x squared over 6 plus 1 over 6. So the integral of 1 over p is simply natural log of p. And this, of course, has to be positive all the times, right? Okay. Because natural log cannot accommodate a negative number, right? Okay. 1 over 6, natural log of p. What was my p? P was x squared plus 1. Okay, x squared plus 1. And yeah, anyway, and then plus c. This time around, you can put a c here because you're done. Okay. You're done now, you can put a c. Okay, and oh, here, even if you don't put absolute values, the modulus is still this number will always be positive, isn't it? Okay. Just by tradition, can put a modulus there. So this is the end of the first question. So guys, watch the next one, because in the next video, I'm going to solve the next problem right now. Okay, so I'm going to find the integral of sine of square root of x. Okay, so that will be done in the next video. Okay, so thank you for your attention. Don't forget to share with your friends and subscribe.